I'm lost.
Yesterday we talked about some basic graphing, right? So we figured out that if the number in front of the x squared is positive, that means the parabola will open up, right? And if the number in front of the x squared is negative, that means the parabola will open down. And then we also figured out that if the number in front of the x squared is bigger than 1, then that will be like a stretch. Kind of like it makes the slope steeper. And then if the number in front of the x squared is a fraction, then it'll widen it out, right? Then we messed around with this a little bit. The minus 5 would do what to the parabola? Move it down 5. The minus 4 inside the parentheses would move it to the right 4 because inside the parentheses is opposite. This plus 3 would move the parabola up 3, and this plus 1 would move it to the left 1. Okay, so what we're going to do today or now is we are going to put that together to figure out some things about the parabola without making a graph. Okay? So the first thing is we are supposed to figure out what the vertex of this parabola would be. Okay? And since there is a minus 4 inside the parentheses, that would move it to the right 4. So hopefully you understand that that means that the x-coordinate of the vertex will be 4. Okay? Because to the right 4 is x equals 4. The minus 2 means that it goes down 2. So that means the y-coordinate of the vertex will be negative 2. Okay? So you can take those things that were happening with it moving left and right and up and down and use them to figure out where the vertex of your translated parabola will be. Okay? All right, then the axis of symmetry is that line, that imaginary line that goes right through the middle of the parabola, right? Okay, and since it goes straight up and down, it's going to have an equation of x equals a number. Okay, the number that it will equal is the x-coordinate of the vertex, because that's where the axis of symmetry will pass through. So once you know that the vertex is at 4, negative 2, it is an easy step to figure out that the axis of symmetry is at what? Right, so you would write x equals 4, because technically that's a line, so we need x equals 4, not just 4, okay? All right, the equation is y equals 3 times x minus 4 squared minus 2, so the 3 is positive, so the parabola opens up. So will the parabola have a maximum or a minimum? It'll be a minimum, right? Because it opens up like this. What will that minimum value be? What's the lowest point on that? Well, before is the x-coordinate, we only need the y-coordinate, so yeah, that will be y equals negative 2. Okay? So as soon as you know what the vertex is, which you can get from just thinking about the transformations that happen, as soon as you know what the vertex is, you also know for free what the axis of symmetry is and where the maximum or minimum will be. Okay? So you have to give it a little bit of thought about whether it's a maximum or a minimum based on whether the parabola opens up or opens down, but that shouldn't be too hard. All right? Okay, then we're supposed to figure out the domain. And the domain, if you recall, is the x-coordinates that the parabola can take on. So if you graph a parabola, how far to the left will it go if you graph it forever? Forever, right? It's going like this, okay? It's going this way, it's going up, but it's also moving to the left, all right? So the domain will start at negative infinity. how far will it go if we graph it this way? Right, positive infinity. And I really don't know why math books always ask you what the domain of a parabola is. It's always, for the domain, negative infinity to infinity. The domain of all parabolas, negative infinity to infinity. Okay? The range is a little bit more interesting. The range is the y values. And so for this parabola here, if the minimum is -2, hopefully you understand that means that the range starts at -2. And then how far does it go? Infinity, forever, ever. Okay? So the range is going to be -2 to infinity. If this had been a maximum instead, then it would be negative infinity up to that point. But since it was a minimum, that means we start there and then go up forever. All right? Mac? Never? Because somebody else called you Mac today? All right. Lindsay, what's your question? For all parabolas, because they go forever that way and forever that way. I thought the other Mac was Mac.
Well, no, she was Mac and I was
Right.
Mac now.
Oh, well, that's what she already did.
Hit the floor and started tipping. My first instinct was to fall on camera.
Okay, got it? Got it? All right, prove it. Vertex of this one is where? -1, 4. Because the +1 inside the parentheses will move it to the left 1, and the +4 outside the parentheses will move it up 4. Okay? So now that you know where the vertex is, you should be able to very easily, quickly tell me what the axis of symmetry is. Nice. X equals what? -1. Okay? The x-coordinate of the vertex is the same as the axis of symmetry. This one has a negative in front, so will it open up or will it open down? It'll open down. So will we have a maximum or a minimum? We'll have a maximum. What will that maximum be? Y equals 4. What?
Y equals 4.
Y equals 4. Okay? Easy one. Domain? Negative infinity to infinity.
Do we have to write that on?
Yep. Range? Okay. Nope. What? No, because it's a maximum. So it's negative infinity to 4. Okay?
I can only be one and one.
All right.
Yeah, mine look like like just. Can I just draw 2 circles?
Sure, man.
Those look like better than
Okay. All right. So, Jordan, got it? Yeah. I don't believe you. I don't believe you.
He hasn't heard a word from that.
I know. I know. All right. So here is all that stuff in summary. Okay. What we've been working with is the vertex form because the h and the k tell you what the vertex of the parabola is. The number in front stretches or compresses the parabola. If it's negative, it flips it over the x-axis. And then h tells you how far it goes side to side. K tells you how far it goes up and down. Okay, so that just kind of summarizes what we just did. The translation of the parabola. All right? So now let's make this into a graph. And let's try and do it without making a table. So we are going to start by finding the vertex. Hold on, don't say anything. Anybody in this class? Jordan,
No, I'm out.
where? You said you got it!
I did got it. That's embarrassing. I'm on page 2.
Okay, somebody else. Yes.
Okay, to the right one.
To the
No.
right one
Yeah, to the right one,
The right
and
one.
up 3.
and up 3. So the vertex is right there, okay? All right, now, I don't know if you remember when we graphed the parent function yesterday, y equals x squared, but we started at the vertex, and then where did we go from there? Up 1, over 1, and then up 3 over 1. And so we were basically doing the, up what? 5. It's the odd numbers. So it's up 1, and then up 3, and then up 5, and then it'd be up 7, right? Okay, this one has a negative 2 in front.
So it's going to be
So-
going down.
Right, so it's going to be going down because it basically takes all these numbers and multiplies them by negative 2. So instead of going up 1, 1 times negative 2 is negative 2, so I'm going to go down 2. And then from there,
Go down
instead of
6.
going up 3, I'm going to go down
6.
6 because negative 2 times 3 is negative 6. So I have to go down 1, 2, 3, 4, 5,
I want
6.
to do that.
Okay, right, and then the next one, if I did it, would be down 10, but that's not going to fit on my graph, so I'm going to take those as being enough, okay? Just so you guys know, we're recording today because Quinn's not here. The microphone's in the laptop, so it's probably picking up every single thing that you are saying, okay? Yes?
So if you had a fraction of x,
Okay?
it would be like just multiplying those by fraction, but it's still, the x is only moving by 1.
Right. Okay,
it's-
so let's say that you had 2/3 x, I don't know, plus 2 squared minus 4, okay? So you would say the plus 2 goes over here, and then the minus 4 goes down 1, 2, 3, 4, right?
Yeah.
So there's your vertex. Okay, now instead of going up 1, you go up 2/3. But yes, you're right, you still go over 1.
Where did
Okay.
you
So
get
it's
that?
never gonna
And then
go
instead of going up 3, 2/3 times 3 is 2. So from here you would go up 1, 2, but you'd still go over 1. Okay?
Okay, where did you get that?
I just made it up because he asked a question and I was explaining it.
Oh.
Okay?
Playing the video.
Okay, so we are not done graphing this one we started with. It's a parabola, right? So all the stuff is reflected across to the other side. And so this point is going to also be here because I'm going to go down 2 over 1 this way. And then I also have to go down 6
You're going
over
to draw a
1
nice pretty line,
from
right?
there. And then we'll make a nice pretty line.
What?
Okay?
We're being recorded.
We're being recorded. All right. Any questions about how I got that? And then hopefully, you recognize that this is a little bit skinnier than normal parabola. Okay. Like I said, normally you'd go over 1 and then, down 1 and then down 3. So this one would be, the parent parabola would be a little bit wider than this one right here. Okay. All right, let's for some random reason make this into a multiple choice. Don't say the answer out loud. Look at the parabola y equals negative 2 times x plus 1 squared plus 3. And then they give you 4 different choices for what in words you would do to graph that parabola. Read the choices, make a decision in your head on your own. What's the answer?
D.
D, okay? There are 4 things going on here. The negative flips it over the x-axis, okay? So this one is no good because it doesn't say flip over the x-axis. The 2 is a stretch of 2. So this one is no good because it doesn't have a stretch of 2. The 1 moves it 1 unit to the left because inside is opposite. So that throws out answer choice A. So that means you know it is D. Okay. All right, so Jordan, you got it? Okay, let's go. What do I do? Tell me in words. What do you do? Okay, I'm going to go to the left 2. Down 5. Almost 2 out of 3. What does this do right here? Okay, yeah, good. Thank you, Riley. That is a
Dude, I already
stretch.
had that, Riley. Thank you very much.
2. Okay? So 3 different things going on here because there's 3 different numbers, right? Each one of the numbers is going to do something different to the parabola. The 2 makes it go to the left 2, the 5 is down 5, and the 2 outside multiplies it by 2 or stretches it by 2. Okay? All right, I screwed up here and I didn't put the picture in here. So good thing Bolton has his book open. We can also come up with the equation for a parabola based on its graph. Okay? So on page 198, there's a picture of a dolphin jumping. And they put a little graph in there to show how its jump would continue. Okay? Here's how this works. You need to find the vertex of the parabola, and then you also need to come up with one other point. All right? What is the vertex of that parabola? The parabola on page 198. 3, 7. Okay? Hold on a sec. You have this dolphin here that's jumping, and we're going to find the equation for the parabola that matches that graph. And so I said the first thing you need to come up with is the coordinates of the vertex. So if you look at the graph over here, the coordinates of the vertex look like they are at 3, 7, right? Okay, you also need to come up with one more point on this graph. Okay, so he said 4, 7. I don't like 4, 7 because it's a little bit below. What did you say? 8, 6, 8, and 5. Doesn't it look like it's a little bit below the 5?
9, 4.
How about 9, 4? 9, 4 to me looks like that's a place where it exactly crosses on the grid line. Okay? If you use the other ones, except with the exception of what Brandon said, that's totally out of the question. Yours would work. Okay? Now, Brandon said, hold on. Brandon said 4, 7. Why do we know for sure that 4, 7 would not work? Okay, but why can we not use 4, 7? Because then that would make it a straight line, right? It has to be below, it has to be going down, okay? All right, anyway, we're going to choose the point 9, 4, all right? Now, you are familiar already with when you take the equation y equals mx plus b, and you want to solve that for b, we took and plugged in a value for x, plugged in a value for y, and plugged in a value for m, right? And then solved it for b. This is the exact same thing, except this time we're solving for a. So we are going to take the vertex form of the equation, y equals a times x minus h squared plus k. And I'm going to put in a value for y. I'm going to put in a value for x. I'm going to put in a value for h. And I'm going to put in a value for k. And then I'm going to use that to solve for a. So it's the same thing as the y equals mx plus b, but it's a little bit more complicated because it's a parabola instead of a straight line. Okay? Which one of those letters that I just named is the 3? H. The vertex of the parabola is h, k. Which one of those letters that I just named is the 9? X. And the 4 is a y. Okay, so the vertex point is going to give you your h and your k. And then the other point that they either give you or that you choose from the graph will give you your x and your y. Okay? All right, so now I'm going to rewrite this with those numbers in there instead. So instead of writing y, I will write 4. A is what I'm trying to figure out. Instead of writing x, I write 9. Instead of writing h, I write 3. And instead of writing k, I write 7. Okay? So all I did was I rewrote the vertex form of the parabola with numbers in there for the x and the y and the h and the k. All right? And now I'm going to solve this for a. What do I do first? Parentheses. So 9 minus 3 is 6. What do I do after inside parentheses? Square it. So 6 squared is 36. Okay, so this gives me 4 equals 36a plus 7. Right? I just did this piece right here in my head. 9 minus 3 is 6. 6 squared is 36. So instead of 8 times all that, it's 36a. Okay? All right. Now how do I solve that for a? Subtract 7. So that means that negative 3 equals 36a. And final step? Divide by 36. So a equals negative 112. All right? Okay, so my final answer, now that I know what h is, I know what k is, and I know what a is, just like when we did this and we figured out what b is, we rewrote the formula with an x and a y in it, right? And then numbers for the slope and for the y-intercept. Same deal here, I'm going to rewrite this formula, but I'm going to keep the x and the y in there, and I'm going to plug in numbers for a and h and k. So my final answer is y equals negative 1/12 times x minus 3 squared plus 7. All right? Yeah. Okay? Tomorrow, we're going to mess around with taking this form and changing it to the standard form, which you're more used to, like 5x squared plus 2x plus 7, and then also how to go from that to this. But for today, we're mostly focused on vertex form, so this is good. All right? Okay, so some of you, I know, will need to start on number 9. Okay? Most of you, hopefully, did some of those problems already. So Casey says, add those on, turn it in as one assignment tomorrow, and you're good.